Hi guys, and welcome to our second crash course. This one's on the circulatory system. So let's jump right in. So the circulatory system, or the cardiovascular system, you may have heard it called, its main purpose is to transport materials throughout our body. So this is how all the important things in our body gets to where it needs to go. So those materials could be oxygen, nutrients, water, hormones, and lots of other stuff. We have three main kind of sections of our circulatory system, and that is the heart, the blood, and the blood vessels. Now, vertebrates have something called a closed circulatory system, and that just means that the fluid, the blood, is contained within a network of tubes. So it's not just able to flow wherever it wants around the body, it is contained in our blood vessels. More specifically, mammals have a two-circuit closed system. So the first circuit is the pulmonary circuit, and that is the part of the circulatory system that delivers blood to and from the lungs. So if we look at our diagram here, this loop where we're going to and from the lungs, that is our pulmonary circuit. And anytime you guys see the word pulmonary, that means something to do with the lungs. The second circuit is called the systemic circuit. So that's the part of the circulatory system that delivers blood to and from the body. So that is going to be this lower loop here. We're going to and from the body. So let's talk about blood first. There's four main components that we need to know about. So red blood cells is the first type. We talked a little bit about them when we looked at the respiratory system, but just a reminder, those are the cells that contain that super important protein called hemoglobin, which is able to pick up oxygen and bring it around the body. Those red blood cells are formed from the stem cells in bone marrow. The next type is white blood cells, or leukocytes, and they fight disease-causing bacteria and viruses. These are our little warriors in our blood vessels that help protect us. So they are also formed in the bone marrow from stem cells as well. The next component are called platelets. And so these are cell fragments that help the blood clot. So they're able to seal off wounds and stop bleeding. So if we break a blood vessel, whether it's a bruise or you actually kind of get a slice on your skin, you'll notice that the blood will start to get thick and form a clot. So that's the platelets that are sticking together. They have a chemical on them that allows them to stick together and kind of seal off the hole so that the blood vessel can rebuild. And the last component is plasma, and that is the actual liquid part. So it's a protein-rich liquid that all these cells and other parts are suspended in. So there's lots of important dissolved ions in the plasma, such as sodium, potassium, and calcium. Okay, let's talk blood vessels. So some key kind of concepts about blood vessels is that they range in size. So the largest blood vessel in your body is about 3 centimeters in diameter, all the way down to just 1 cell thick. So they definitely range in size. They also touch every single cell in your body because every cell needs oxygen. So they have to get that from those blood vessels, which is why the blood vessels get so tiny so that they can touch every cell in your body. We have 3 main types of blood vessels that we're going to look at. The first, you probably have seen these names before, is arteries, veins, and capillaries. Let's talk arteries. So arteries, and these are named because of the direction they're carrying blood. So arteries are any vessels that carry blood away from the heart. And a trick that I always use to remember this is they both start with A. So arteries carry blood away. So the arteries themselves are under high blood pressure because we're forcing a whole bunch of blood out of our heart and into these vessels. So the blood is under high pressure when it's going through the arteries. To compensate for this, arteries have thick, elastic, and muscular walls that can kind of stretch to allow that big amount of volume of blood to come through them. As we get further away from the heart, so as we're carrying the blood away from the heart, our arteries branch away like trees. So the branches are going to get smaller and smaller, and then the smallest type of arteries is called arterioles, and they can receive signals from our nervous system that can regulate the diameter, so kind of the size of the vessel. So vasodilation is when we increase that diameter. So if you picture the vessel getting a little bit bigger, it's allowing more blood to be flowing through it. So if you get a flushed face, if you get that red face, whether you're working out or you're nervous about something, that's the blood vessels in your face that are vasodilating. And then the opposite of that is vasoconstriction. So they're kind of squeezing tighter, they're decreasing in diameter, and that will decrease the blood flow that is able to go through them. The next type was veins. So remember, arteries carry blood away from the heart, veins carry blood back into the heart. And my trick to remember this is veins has IN for in, and it's bringing blood back into the heart. So the blood has kind of circulated around our body now. It's not being forced out of the heart. So the blood is under low pressure in the veins. So because of that, the walls are a lot thinner. They don't need to be that thick, elastic, muscular walls. They can be a lot thinner. Now they also have a really cool thing called these one-way valves. And so this helps the blood continue to flow in the right way. So if you think about blood that's made it all the way down to your feet, it now needs to come all the way back up to your heart. So there's no pump in your feet that will push that blood back up to your heart. Instead, we have these valves. So as the blood is being pushed back through the circulatory system, these valves allow it to be pushed upwards, but then not fall back downwards. So that kind of helps us not have a whole pooling of blood happening in our feet. That's kind of just what I just said, just that we're able to keep the blood flowing in the correct direction, and it can actually flow against gravity, which is pretty neat. So just like arterioles are the small version of our arteries, venules are the small versions of veins. So except think that we're going in the opposite direction here. This picture can help. So if these are the arteries, as we branch smaller and smaller, we've got arterioles, but then on the other side, we've got our venules that come together to form veins. So it's kind of working in the opposite way. So venules are formed by the merging of capillaries. Speaking of capillaries, so blood vessels are largest near the heart. As we get farther and farther away, they're branching into smaller and smaller vessels. Eventually, when arterioles get small enough, they are called capillaries. So right here in the middle, where we see this kind of mix, we've got the smallest blood vessels, which are capillaries. Capillary walls are only 1 cell thick, so they're super, super tiny. These are the blood vessels that are going to be able to reach all the cells in your body. And the fact that they're so small is helpful because it actually allows nutrients and oxygen to easily diffuse from the blood into the cells. They're actually so small, these capillaries, that red blood cells can only travel through them in single file. So you guys don't have this on your sheet, and you do not need to worry about memorizing all these names, but these are some of the major blood vessels that we see in our bodies. You may recognize some of these names. So the aorta is our biggest blood vessel. It is the artery that all of the blood from the heart is going to be pumped through before it branches away into other arteries. The carotid artery is the one that brings all our blood up to our brain. Without that guy, or if that artery got cut somehow, you would be toast pretty quickly. Coming back from the brain, our blood comes through the jugular veins. If you've ever heard in kind of the wild how big cats will go straight for the jugular, that's because they're smart and they know that if they get that one, you're also probably toast pretty quick. We see that word pulmonary again. So remember, pulmonary has to do with the lungs. So pulmonary arteries are bringing blood to the lungs. Pulmonary veins are bringing blood back from the lungs. Let's see what else. Brachial means arms. Renal means the kidneys. Gastric, we're bringing blood to our digestive system. So there's lots of really important ones. Okay, the heart. So the heart is a muscular pump that supplies blood to all parts of our body. We're going to kind of separate the heart into 3 sections to look at. So the first are the chambers. So we have the left and right atrium, which are the collectors of blood. So all incoming blood into the heart will collect in the atria. Then we have the left and right ventricles, which are the pumps. So they're the muscle part that's actually pumping the blood out to the body. Our next section is the vessels. So we've got sort of 4 main ones that feed into the heart that we want to look at. So the first is the superior and inferior vena cava. So that's returning all deoxygenated blood from the body back to the heart. The pulmonary artery, we kind of just talked about, that's bringing deoxygenated blood from the heart to the lungs. The pulmonary veins are bringing oxygenated blood from the lungs back to the heart. And that big one, the aorta, largest blood vessel in the body, is bringing oxygenated blood from the heart to the body. One thing I want you guys to put a little star beside is that the pulmonary artery is the only artery that carries deoxygenated blood. So all other arteries carry oxygenated blood. The pulmonary artery is the only one that carries deoxygenated blood. And similarly, the pulmonary vein is the only vein in the body that carries oxygenated blood. So then the last section is the valves. So just like in our veins, these are one-way valves that only allow the blood to go in one direction. So there's 2 types. There's atrioventricular valves, and that connects the atria to the ventricles. So if we look at that word, a good way to remember it is atrio looks like atrium, ventricular looks like ventricles. So we're connecting the atrium to the ventricles. And then we have semilunar valves that connect the ventricles to the aorta and the pulmonary arteries. So let's look at an actual diagram of this. You want to fill out the little labels as we go. Okay, so first of all, I want to point out we're going to use 2 different symbols. We're going to use red smiley guy to represent oxygenated blood and the blue smiley to represent deoxygenated blood. All that means is the deoxygenated blood does not have oxygen in it. The oxygenated blood does have oxygen in it. So we're going to start up here and follow as we go along. So blood is returning from the body. It is just circulated through the body, and it is coming back through the 2 major blood vessels called the superior and inferior vena cava. That blood is going to collect in the right atrium. Now you might be thinking, hold up, that's on the left. So this is as if you were looking at a person who is facing you. So that would technically be their right side of their body. So we're looking at a mirror image here. Okay, so the blood is collected in the right atrium. Now here's our first valve. So that's the first atrioventricular valve. So the blood is able to flow out of the atrium into the ventricle, but then not back. So once we go through that valve, we are in the right ventricle. Now, this thick part at the bottom here is all muscle. So when that squeezes, the blood is going to be forced up through the semilunar valve and out the pulmonary arteries. So remember, pulmonary means lungs, so that deoxygenated blood is going to the lungs so that it can pick up new fresh oxygen. So when the oxygenated blood comes back from the lungs, it's going to return via the pulmonary veins. That blood is going to collect in the left atrium. We go through another atrioventricular valve, and now we are in the left ventricle. This is the most muscly part of our heart. So you can see that thick layer of muscle around the left ventricle, and that's because this part needs to be really strong so that it can pump the blood to the rest of the body. So when that part squeezes, we're going to be forced up through the second semilunar valve and out through the aorta. Now, the only other part I want to point out is this muscular separation here. It separates the left and right side of our heart, and that's called the septum. So we're going to watch a short video on how the heart pumps blood.
For most of history, humans had no idea what purpose the heart served. In fact, the organ so confused Leonardo da Vinci that he gave up studying it. Although everyone could feel their own heart beating, it wasn't always clear what each thump was achieving. Now we know that the heart pumps blood. But that fact wasn't always obvious, because if a heart was exposed or taken out, the body would perish quickly. It's also impossible to see through the blood vessels, and even if that were possible, the blood itself is opaque, making it difficult to see the heart valves working. Even in the 21st century, only a few people in surgery teams have actually seen a working heart. Internet searches for heart function point to crude models, diagrams, or animations that don't really show how it works. It's as if there has been a centuries-old conspiracy amongst teachers and students to accept that heart function cannot be demonstrated, meaning that the next best thing is simply to cut it open and label the parts. That way, students might not fully grasp the way it works, but can superficially understand it, learning such concepts as, the heart is a four-chambered organ, or potentially misleading statements like, mammals have a dual circulation, one with blood going to the lungs and back, and another to the body and back. In reality, mammals have a figure-8 circulation. Blood goes from one heart pump to the lungs, back to the second heart pump, which sends it to the body, and then back to the first pump. That's an important difference because it marks two completely different morphologies. This confusion makes many students wary of the heart in biology lessons, thinking it signals an intimidating subject, full of complicated names and diagrams. Only those who end up studying medicine completely understand how it all actually works. That's when its functions become apparent, as medics get to observe the motion of the heart's valves. So, let's imagine you're a medic for a day. What you'll need to get started is a whole, fresh heart, like one from a sheep or pig. Immerse this heart in water, and you'll see that it doesn't pump when squeezed by hand. That's because water doesn't enter the heart cleanly enough for the pumping mechanism to work. We can solve this problem in an extraordinarily simple way. Simply identify the two atria and cut them off, trimming them down to the tops of the ventricles. This makes the heart look less complicated, because the atria have several incoming veins attached, so without them there, the only vessels remaining are the two major heart arteries, the aorta and pulmonary artery, which rise like white columns from between the ventricles. It looks, and really is, very simple. If you run water into the right ventricle from a tap, the left also works, but less spectacularly, you'll see that the ventricular valve tries to close against the incoming stream, and the ventricle inflates with water. Squeeze the ventricle, and a stream of water squirts out of the pulmonary artery. The ventricular valves, called the tricuspid in the right ventricle and the mitral in the left, can be seen through the clear water opening and closing like parachutes, as the ventricle is rhythmically squeezed. This flow of water mimics the flow of blood in life. The valves are completely efficient. You'll notice they don't leak at all when the ventricles are squeezed. Over time, they also close against each other, with very little wear and tear, which explains how this mechanism continues to work seamlessly for more than 2 billion beats a heart gives in its lifetime. Now, anyone studying the heart can hold one in their hands, make it pump for real, and watch the action unfold. So place your hand above your own and feel its rhythmic beat. Understanding how this dependable inner pump works gives new resonance to the feeling you get when you run a race, drink too much caffeine, or catch the eye of the one you love.
Okay, so one thing to note, that video does point out that, oh, sorry guys.
It's often
Okay. So one thing to note, that video does say that saying we have a two system circulatory system can be confusing. They're right. So the blood is constantly circulating through both the pulmonary and systemic systems, but we do make the distinction. We do call it a two-circuit system because there is part of it that's going to the lungs and part of it that's going to the body. So that was just something I noticed in the video and wanted to point out. All right, last but not least, so how do we check our circulatory system? There's three main ways. The first is just like what we did in class, so you can check your pulse, which tells you how quickly your heart is beating. The next way is you can take a blood sample, so they can test levels of red and white blood cells, blood sugar, hormone levels, all sorts of stuff they can tell from your blood. And then the last way is to measure your blood pressure. So I don't know if you guys have ever had that kind of cuff put on your arm and it inflates as they squeeze it, and it gives them a reading of blood pressure. But that is also a really good indication of how healthy your circulatory system is working. Now, when we take blood pressure, we get two numbers. So an average blood pressure reading could be 120/80. And that just means that we've got kind of two different pressures that we're looking at. So the first is systolic pressure. So that's the pressure when the ventricles contract. So that's when they're filled with blood, the muscles are squeezing and pushing that blood out. So that's really high pressure at that point. And then diastolic is when they're relaxed and they're filling up with blood. So they're under lower pressure in the diastolic phase. So when you get that reading that your blood pressure is 120/80, the 120 is referring to your systolic blood pressure and the 80 is referencing your diastolic blood pressure. And that brings us to the end of the circulatory system.